Yeah, my name is Carlos Tapang. I'm glad to be here. I worked in the U.S. for I don't know how many years now, probably 20 years. I came back here because I like Cebu. I work for Microsoft, and I need to let you know that even in Microsoft, things like Stack Overflow are searched. And yeah, every engineer knows about Stack Overflow. However, if you've been using Bing.com, there was an accusation at one time that Bing.com doesn't show too many results from Stack Overflow. I tried it last night. It did show a couple, so I think that's an improvement. So I would recommend Bing.com to you too. I'm not currently a Microsoft employee.
Just an evangelist.
Just an evangelist, yeah. Probably the best summary I can get of working for Microsoft is the dictum that says, eat your own dog food. How many have heard about that? You've heard about it? Okay, good. I do not work for a product group. I work for the IT department. The IT department of Microsoft. Our mission really is twofold. One is to provide IT services to the whole company. And the other one is actually to eat the dog food. So we use beta products, we use alpha products. And so when my son was saying, you work for the IT department, not a product development? I mean, that's not exciting, isn't it? I told him, it's more exciting than product development in my view because we get to eat the dog food from the product development group. I have also been a physics instructor at the University of the Philippines in Manila. That was a long time ago. I don't want to reveal how old I am, but I graduated physics from Ateneo de Manila University, and teaching physics to non-science graduates, non-science majors was very interesting because, of course, you get to do all kinds of things. Like to teach waves, I take them to the swimming pool, and create waves in the pool. I think I'm very good at teaching subjects that are difficult to grasp, and I think that's the subject that I am going to talk about today. Is about object-oriented programming. As for my favorite game, I don't really play lots of games, but I do have a game on iPhone. It's called Slasher Derby. It's a free game, so you can download it. I actually built it for Manny Pacquiao. Unfortunately, he did see it and he liked it, but he didn't sign up for it because his lawyer told him that he couldn't. He already had an agreement with EA Sports. So. Anyway, I do have a game on the iPhone. Okay. Let's move forward. So I have questions. How many are developers here? Programmers, developers? I guess most everybody, right? Have you studied object-oriented programming in college? Mostly, right? Can I have a hand? How many people have taken up? Okay, yeah, I think most of you. So I think most of you know about this subject. How many of you would say that, how many of you are actually applying OO concepts at work? Show of hands, please. Okay, great. And how many of you would say that OO concepts are hard? I think it's hard. It took me a while to get it. I didn't take it in college. I had to do some trainings myself to go through it. I didn't read the Gang of Four. I basically learned it through a lot of training and a lot of learning on my own. So that's interesting. Okay, let's talk about building a wildlife game as an example into basically this concept that I'm about to talk about. we have basically 4 requirements. The game itself, of course, is a big project. These requirements are going to be only part of the whole project. And the rendering engine needs to know whether an animal needs to be rendered or not. And in order to do that, we have these 4 requirements within that project of the game. So first, each type of animal can have a different number of legs. And an animal objects must be able to remember and retrieve this information, which is very simple, right? Nothing difficult in that. And each type of animal can have a different type of movement. Nothing special about that. And then animal objects must be able to return how long it will take to move from one place to another, given a specified type of terrain. So, given those 4 requirements, let's have a first cut design. This is, of course, an object-oriented design. We have 2 classes deriving from the same animal. And we have a property called movement in the animal class, and that property is an enum. Now, is there anything that is unusual about these declarations here? I just copy-pasted the property num-legs, right? And that's not really necessary, right? Because we can declare that in the animal class itself. So the whole point here of this slide is that by using object-oriented language, we are able to prevent having to copy-paste properties of classes. Because by putting it there, both the mammal and the reptile animals inherit that property. Now let's take note of the movement property member. That is the key to this design. We declare the num-legs public to comply with the second requirement, right? And then we have the movement property as an enum. And of course that will imply something in your implementation. And I will show that. But we are still missing the 4th requirement. And to do the 4th requirement, we add a method called speed, which will allow us to tell whether an animal is going to be within the range of what needs to be rendered or not. Are you with me so far?
So when you say virtual function for animal, that next animal then abstract class obviously. Like there's no implementation of speed for animal. That's your meaning of virtual. Sorry, there's no.
Yes, actually this is C# and you're talking Java. Yes.
No, I'm talking C++.
Okay, yeah, you're right. C++.
Yeah.
Right. So, yeah, virtual means in C#, this is, by the way, C#, I'm sorry. Virtual simply means that you can override it. That's what it is in C#.
Right, but is there an implementation of the method speed in the class animal?
Yes, there is.
Okay.
You can have it, yeah.
Okay.
And I think it's the same in C++. You can also have an implementation of that, right?
Well, that's my next question. In C++, you would go like equals 0, which is fucking stupid, and
right.
it would be like that. And make the class abstract. So that's basically my question, is animal an abstract class or not?
In this case, it's strictly speaking, no, it's not an abstract class.
Okay.
Yeah, in the C++ sense.
Alright.
This is simply, this is the way that the C# is in Java, in fact. You don't need to say it's virtual, right? In Java, you can override everything. In C#, you have to say that you're wanting to override. And this is actually a good question because as you will notice, we override the speed method in both the mammal and the reptile.
Can I interrupt? In C++, I'm not so sure about the other languages. Virtual doesn't mean you can override it. Virtual means we're going to use the most heavily derived version of the function. So let's say if you have an animal class that has a function that says walk, then in your mammal class it says walk. So if you're not declaring it as virtual and you have a base class pointer that's pointing to your mammal, it's the animal version of the function that's going to be called. But if you say that it's virtual, you're using the most heavily derived version of the function. So in this case, the most heavily derived version of the function is mammal. So it's not really, when you say virtual, it's not really saying that you're forcing people to override it. So when you force people to override that version of the function, you just add, at least in C++, you add equals 0. So you're saying the base class is not going to implement this. It's going to be implemented by the extending class.
Yeah, I think that's the case in C++. Yeah, equals 0 means it's really abstract and you need to implement it in the derived class. Yeah, in C# it's different. When you say virtual, it simply means it can be overridden. And in fact, it can also be implemented in the animal class, which is interesting. Because now what happens is, even if you override it here, you can still call. You can say base.speed, and it's going to call this what's in the base class. So those are language differences. But I think in the most part, my point here is that we have two implementations of speed, one for mammal and one for reptile. Why? Because for every case here of a mammal, we need to consider what the movement will be, right? And if we just have it here in the animal class itself, we will have too many cases to handle in the animal class. Am I okay in time here? Better do it faster now. Okay, so this is a close-up of the speed method. In here, what I did is just simply copy-paste the switch statement for a mammal and for a bird. Nothing exceptional there. But the main point, again, of this slide is that because we're using an enum to indicate movement, we will have to implement a switch statement in every class that's relevant to it. Now this is, after the copy-paste, of course, we need to be more specific about each of the cases. For example, for a mammal, a bat, I suppose, is a mammal, right? But it can fly. So this is an exception here, and you have to take that into account. Now, the bird can both walk and fly. So you have to have cases for walking speed and bird flying speed. By the way, in C# you don't need a break here because when you return, of course, you got the method. Okay, so this is now the second cut design here. Well, let me go back to that first. Talking about walking speed, there's a big problem here because for the case of walking, right, the bird and the mammal, especially if the mammalian is also two-legged, that's going to be exactly the same case, right? There's basically no difference. A bird walking is the same as a two-legged animal walking. And so we will be doing a lot of copy-pasting. In fact, the question is, this method here, walking speed, do we copy-paste that in one class and another? Or do we just call the method in another class from the other class? In other words, should I implement it here in the mammal? And then should I just simply call it from the bird class? The method that I declared here in the mammal. There's a, I think I just turned it off. It's okay, I think I'll just talk without the mic. Is that okay? I think everybody can hear me anyway, right? Yeah.
Yeah.
Okay. Am I getting you there? The fact that walking speed can be either called as a method or it can be copy-pasted. And there are advantages and disadvantages to both. The big disadvantage, of course, if you copy-paste, is that it will be difficult to maintain the code. Any small change that you do to the walking speed, you will have to do in all the classes that you implemented already, right? And if you make a mistake in one, or if you forget to change it in one class, and change it only in the rest of the classes, then you will have a bug that will be very difficult to find. So that's the big disadvantage. So let's go to the second cut design. There's a better way of doing this, right? So this idea here is to classify animals according to mode of movement. Now what's the advantage here? First, the advantage, one of the advantages is now we get rid of the enum, right? But the disadvantage is there will still be big exceptions, and we'll go through that.
But didn't you say before that birds can walk and fly?
Yes, exactly. That's the disadvantage here. There will be exceptions.
All right.
There will be exceptions to the rule, and in fact, there will be more exceptions than the rule themselves. Yes. So this is a more detailed view of that. We have animal that flies, animal that walks. Two basic classifications. Of course, there's also animals that slither, right? We can add more to that. And the problem is, like you said, there are animals that can both fly and walk. So here, in our implementation of bird, we will have to take that into consideration. Right? So we will have exceptions here in this method. So that's a disadvantage of this. Even though we got rid of the enum, right, by having this classification, the problem then is that we have a description, a model of the world that's basically non-realistic. I mean, there's going to be more exceptions than the rules themselves. Now, this is the third cut design. I'm going faster because I think I'm out of time already, right? In this design, what we did is similar to the first design, the first cut design, but instead of using an enum here to declare movement, we're using a class, animal movement. And in that class, we can define as many types of movements as we want. Now, what is the advantage of this? The advantage is that now implementing the speed method is going to be much, much simpler. The type of animal it is, really, in this implementation, has nothing to do with the type of movement that it can do. That's my 20 minutes. You want me to go on, or? Okay. So we remove the details of movement from the definition of what type of animal it is. But however, because of object-orientedness, whenever we call speed on this mammal, it will know which speed to execute. Can you see how that is? Let's do some more details here of the implementation. So I have movement declared as a class in itself, and I have this constructor here of animal. When I construct animal, I also assign an object, animal movement object to movement. I give it a parameter, which is this object, and so when it gets here, animal movement will also know about animal. So it's actually a two-way street there. I know about animal movement, being an animal, but being an animal movement, I can also know things about animal itself. And I use that to do the calc speed here, because all I'm really interested in is the number of legs, the speed factor, which I added just now, and the terrain. So if I call speed from here, from an object that's declared as a mammal, it will call the base class speed, right? And then the base class speed is going to call the movement speed, this one. And I have all the factors I need there to calculate speed. So this is much simpler and much easier to deal with. Another advantage, of course, is like I said, you can add as many movements as you can think of here, and it won't really matter. It will be independent of your code for both mammal and reptile. And by the way, this design, it could either be, I think it's either called a bridge or a strategy, I'm not sure. But it's one of the very popular design patterns. Okay, so that's basically it. And to conclude, if you find that you're doing too much copy paste, it may be time for you to take a look at your design. But it's not really practical. Once you have written your code and people have tested it, I mean, how much effort is there to actually change it? It's very expensive, right? So nobody really does it. Once you've done code, it's there, and it will stay there forever. It's difficult to change software, and part of the reason it's difficult is because it's not really object-oriented. If we do object-oriented design, I think it's going to be much easier to change. Because if we go back here, I can change this here without affecting the code that I have here, right? And yet, whenever I use speed here, I'm using that. I'm not bothering with whatever code I have here. So, I say that design patterns is really really good to learn. I think it's going to be beneficial for everybody. And that's why I am going to be conducting a seminar on the 23rd right here in Cebu on design patterns. And I would like to know how many people would be interested in it. June 23rd. It's going to be a one-day seminar, and it's not free, and that's what I'd like to find out. How much is it worth to you? This kind of thing. I mean, you know. You need to be approved in the company, or? How many would go if I charge 4,000 per person for a full day seminar, including lunch? 4,000 pesos. About 3,000 pesos. I earn money myself. I can be your teacher, but if you don't pay me, then I can't do it.
By the way, I'm also a big design pattern fan, so I would recommend reading the book entitled Design Patterns. The actual name of the book, its nickname is The Gang of Four. A really boring book, but if you just like cut it out, you'll be a better programmer after it.
Yeah, that's very good, Darrell, that you were able to dig through that. And I couldn't read it. It's very bad. I underwent training, and I organized this seminar to make it easy for everybody to understand. And I hope I have shown you how easy it can be. But if not, we'll make it easy for you. How about you give me your design problem before the seminar, and then we can talk about the design problem during the seminar. I'm willing to do that. I will choose one design problem that I will take up during the seminar. 3,000 pesos.
Design problems,
I have more than you can count.
Yeah, well, we'll have to choose one of those.
Any other questions?
Can I make a comment? Can you back up to the last chart that had a picture on it? So this is actually the general concept, if you want to research this, is modifying an object's behavior through composition or aggregation. If you Google that, you'll probably get a lot of hits. So people that don't know C++, probably the first attempt at doing something like this is kind of what you did, right, where they replicate the code in every class. People that think they know C++, the next step that they take is they try and take all that code, and instead of cutting and pasting it, they try and create an inheritance hierarchy to implement functions or methods once, right? And basically, the point is that if you have an inheritance hierarchy that's very deep and has D derived from C, derived from E, derived from A, then you've probably done something wrong. And using this pattern, so what he's shown you, this pattern is very good, very powerful. In fact, if you've done any iOS programming at all, you should recognize this pattern as being basically the delegate pattern for the view controller. So basically, every view controller generally has a delegate, and it's exactly the same pattern.
Yeah, there's this joke like.
Be on your best behavior, Harold. Come on. You said you would.
In C, we have what we call spaghetti code, right?
Yes.
So in C++, we have lots of layers, so we call it lasagna code.
But I think that's C++ you can control it.
In C++, you get a mixture of like spaghetti code inside lasagna code. More ways to hammer yourself. While we prepare for Greg, we have donuts.
Yay!
Sorry. And we have cheap coffee, 3 in 1. So if you want, you can just come here. We don't have a... Yeah, Melody is getting theirs.